Our learner objectives for today are for you to be able to say that you can define air pressure, determine what happens to air pressure with a change of elevation or altitude, identify the two types of air pressure zones, determine what type of weather will occur as an air pressure zone moves into an area, determine what wind is and what causes it to occur, and to identify global wind patterns. We talked about pressure before, but air pressure is a little bit different, but also using a lot of the same principles. Pressure, in general, is the force pushing on an area or a surface. So when you look at air pressure, we're looking at the weight of the atmosphere exerting a force on surfaces, including us. Air pressure is the result of the weight of the column of air pushing down on a certain area. When we look at air pressure and we try to quantify it, if we are at sea level, the air pressure is about 15 pounds per square inch. So that's something to keep in mind when we're trying to calculate it. So at sea level, if you think about it, air molecules are much closer together, making air more dense. If you look at our diagram over here, when we look at the air molecules in the higher pressure areas, the air is much closer together, or the molecules are closer together, making it more dense. If you think about some of the examples we've given you before, if you had a stack of books, the book on the bottom has much more pressure, if it's 6 books on top of it, than the second book in the stack. So the book that's second from the top only has one book putting pressure on it. So this is very much like the same situation here, except we're not talking about books, we're really talking about air molecules. There are many more air molecules at sea level, and they're much more basically together. They're much more condensed. That makes them basically more just higher density. And then if you look at the top where we start to gain elevation, you end up seeing those gas molecules spread apart. So we have lower pressure there, higher pressure down below. At higher altitudes, those air molecules are spread out, making air less dense in general. Now when we calculate air pressure, we take area, which is really length times width, times the air pressure. So if the air pressure at sea level is 15 pounds per square inch, then if we want to find the pounds of pressure on something, we take the example we're giving is an object has 6 inches squared, and if the calculation is multiplied by 15 pounds per square inch, 6 inches squared times 15 pounds per square inch gives us 90 pounds. So why don't we get crushed by the air above us? Well, the air pressure occurs in all directions. So air molecules in the atmosphere are being pushed in all directions, up, down, and sideways. So as air pressure decreases as the altitude increases. So there are less gas molecules as the altitude increases. So at sea level, your O2 levels are at about 21% of the air composition. As you get higher here, you can see that those air molecules in the same space, there's less of a percentage there. So if you look at our diagram here, this entire area is putting pressure on the ground. But when you look up here, the smaller area, there's a whole lot less pressure contributed from this area here than there is from this entire area, or even this area down below. Air pressure, we really have different air pressure zones. So a low air pressure zone will bring bad weather because the warmer air is moving in an upward direction. They usually produce high winds, clouds, precipitation, and other bad storms like tropical storms and cyclones. So if you look at our diagram here, when we look at the low pressure, it's considered the cyclone pressure, or the cyclone example. Basically, the winds are all rising, the hot air rises, and it creates that stormy, cloudy weather. when we look at the high pressure or the high air pressure zones, that is actually the opposite. It brings fair weather because the colder air is moving in a downward direction. So we're looking at this part right here. This is called the anticyclone. So it is not the result of bad or resulting in bad weather. We have calm, clear weather. The cold air is sinking here and the winds are diverging. So these zones move clockwise in the northern hemisphere and counterclockwise in the southern hemisphere because of the Coriolis effect. So just remember that when we have high pressure zones, we have calm, clear weather. Low pressure zones, that's when all of this hot air, that's all those gas molecules spreading apart, it's rising, and because of that, basically we've got a lower pressure area, and lower pressure means stormy, cloudy weather. So what does this all mean? Well, this is where we get wind. Wind occurs when air moves from high air pressure zones to low air pressure zones.